Hello, my name is Karina, and in this video I'm going to show you how we can use dynamic factor models for forecasting values for machines in an Industry 4.0 scenario. Using information from all data series for forecasting is difficult since the number of coefficients increases quite quickly. For example, with 20 series, 400 coefficients need to be estimated. The dynamic factor model uses the information of the entire system by extracting a few latent, unobserved factors from all data series. This small number of factors can explain the dynamic co-movements of many series and are used for forecasting the individual series. Another possible use is disentangling the dynamic of the system. For example, a marketing publication, shown later, disentangles the impact of advertising in the first factor, consumer interest in seeking information about the product before making a purchase decision, and the second factor, the extent to which consumer interest is converted into sales. Dynamic factor models can also handle large data sets. So in this scenario, we have several machines that are connected, one of them containing a gas mixture of ethylene and carbon monoxide. We measure this particular mixture, and the values are then forecasted and given to a connected machine, for example, for controlling a threshold or for real-time monitoring. So here we see the data. On the left is the time index, and on the right, the values of the 8 sensors. The plots do not seem very dynamic if we look at them all together. But if we look at the individual series, we see more dynamic movement that we could potentially exploit for forecasting. The extracted factors, in our case 2, look like this. They're scaled and transformed, and here is where the aforementioned untangling happens, where the factors can possibly be identified for different dynamics of the system. And here we have the forecasted series. The red dotted line shows the last available data point, and to the right of the line we can see the forecast for the next 10 values. This data is then given to another machine for real-time process monitoring. We are confident that we can improve your forecasts if the data is in a factor structure. This can easily be seen in the data, and the forecast accuracy can be measured, for example, by relative MSE and other statistical tools. However, this is only possible if the structure is available. It can't be imposed on the data. So let's take a look at the theory. Here is the main equation with the common part, and here is the idiosyncratic part. The factor evolution is modeled as a vector autoregressive system, and the same is true for the idiosyncratic part, with the coefficients being diagonal matrices. And here we have a more intuitive representation with 2 factor lags. The first lag of the common part is the lag 0, the contemporaneous lag, and the factor evolution consists of 3 lags, but the idiosyncratic part has only 1 lag. And another representation with different lag specification is this one with 3 lags for the factors, 1 for the factor evolution and 2 for the idiosyncratic part. The main theory is taken from macroeconomics from Stock and Watson, and there are different variations of the formula. Here are 2 examples. And Stock and Watson state that the dynamic factor models are also used in astrophysics and genomics, and we found many more application examples, such as in process monitoring, such as in our previous example, energy market for predicting electricity price, telecommunications market, marketing research, here's the publication that we mentioned earlier, business research, environmental science, hydrology, here again some disentangling, medical science, psychology, and last but not least, emotions before and after marriage. We believe that dynamic factor models can improve your forecasts if the factor structure is given. If you are interested in using dynamic factor models for your business, please contact us under info@appstam.com. We are a Berlin-based company where strict data protection laws apply, and as such, it is possible to transfer the data through a Swiss cloud storage provider with end-to-end encryption. Thanks for watching.